Greetings everyone, this is Luandile here, the leader and the instructor of Maneko School. Today we're actually going to be doing exercise 2.11. As you guys can see, I've already created my class, and I've called it exercise 2.11C, which simply says that it's from students' perspective. And I've also put this link on top of my main method so that you guys will be able to get your own copy of this textbook we're actually going through. Here's the cover. So right now we want to do exercise 2.11, and if you haven't read the question, you can go through it. We are actually required to rewrite exercise 1.11 to prompt the user to enter the number of years and displays the population after the number of years. So we gotta use the hint in programming exercise 1.1 for this program. The population should be cast into an integer. So here is the sample run. They gave us the sample run, and if you haven't checked out my video on exercise 1.11, I strongly suggest you do. However, I am gonna go take a look at it. It's actually on page exercise 1.11. It's actually on page 54, as you guys see. Okay, so the US Census Bureau projects population based on the following assumptions: 1 birth in every 7 seconds, 1 death in every 13 seconds, 1 new immigrant in every 45 seconds. So we gotta write a program to display the population for each of the next 5 years. We assume the current population is that number, and 1 year has the 365 days. So the hint here is, in Java, if 2 integers perform division, the result is an integer. The fractional part is truncated. For example, 5 over 4 is 1, not 1.25, and 10 over 4 is 2, not 2.5. To get an accurate result with the fractional part, one of the values involved in the division must be a number with a decimal point. For example, 5.0 over 4 is actually 1.5, and 10 over 4.0 is actually 2.5. So now let's get back to our question. I am not going to read it again though, because I did a moment ago. But I'm gonna let you guys have a look at it. Now that you're done looking at it, we will simply go to our IDE, and then we're gonna get our hands dirty with the solution. So I asked people to actually comment on my previous tutorial on this exercise, and if they didn't, it's totally understandable. It's okay. It's not like you have to. It's up to you. It's your choice. But I always strongly suggest that you do what I ask you to do, because that way you are gonna improve. You are gonna see like what's the point of this channel here. And if you decide not to attempt these solutions by yourself, not to engage on this channel, if you decide not to engage yourself on this channel, I mean, you're probably maximizing your chances of being less. You're actually maximizing your chances of improving out of this channel here. So that's why I always strongly suggest you put comments. You like it, you like my video, or dislike them. It's totally up to you. Okay, with that being said, now let's jump on to our solution. We'll simply go final, int 1 second in an hour. And if you remember well, so how many seconds are there in an hour? You have 30 minutes. We've got 60 minutes in an hour, and we've got 60 seconds in a minute. So it's basically 60 times 60, which is 3,600. Right? Okay. So as I was saying, on our previous tutorial, what we did is we had a bunch of constant, not a bunch, but two, if not three of them, on top of our main method. The reason being, like, it's optional. You can put your main method, your constant, on top of your main method, because they will also be accessible on your main method. However, usually you do that if you got more than one method which actually use those constant. But I don't want to go deeper into methods. I just thought you guys gotta know, like, why would you even put those constant outside the main method? However, this is the most convincing solution out of the ones you'll have on exercise 2.11. So what other constant do we need? No, in fact, I've gotta go seconds in a day. That will simply be 24 multiplied by seconds in an hour. It's supposed to put seconds in an hour. Okay, what else? We want to know how many seconds. In fact, we do know how many seconds. We can find how many seconds are there, seconds in a year. That will be simply 365 multiplied by number of seconds in a day. Okay, once we get that, it's time we actually declare our initialize our initial population size. Initial population size, which is, let me simply copy and paste that number. Oh, actually it's not here. So what I'll simply do is, because I had it somewhere, let me check it on these papers I have here. Okay, it's actually 3,1,2,0,32,486. Oh damn, I was actually looking away. No wonder I was punching these numbers and yet nothing came out. Okay, it was actually 3,1,2,0,32,486. Okay, now that we've got these constants, what we want to do is to get started with actually displaying something on screen. So system.out.print we'll simply go enter number of years, enter number of years. Okay, we then go, there's something I want to do. Something that might freak you guys out. I don't know though, but let's try it. this is what I will do. I will simply declare a variable that will hold number of years instead of creating a scanner and then closing it. What I will simply do, I will go number of years. I will do it differently this time around. I'll just go new scanner system.in. You see this whole thing, it's actually creating a scanner, and usually we've been putting this whole thing, we've been assigning this whole thing to some variable, call it input for instance. So what we want to do now is to actually invoke the next int method on this thing here. So we basically won't be having a variable that is there in order to deal with the scanner. We'll simply create a scanner. You would say perhaps an anonymous scanner, and then use the next int method. And if you're not quite clear, you can put the question down below on the comments. How does this thing work? But it does work, I can assure you of that. However, in such a situation, you cannot close your scanner, because in order to do that, you would need a variable to hold your scanner. Okay, what else we want to do? We simply want to calculate. Now we gotta calculate the number of seconds in an hour. In fact, we don't. What we can do is we can simply, let's do it differently this time around. We can simply have a variable, call it final population size. We initialize it to this size over here. We initialize it to the initial population. We then go final population size. On that, we've got to add, before I do that, you see, you guys, in programming, you happen to think of one thing, and then next thing you know that in order to do that, there's something else that is required to be done first. Okay, and right now I'm actually thinking of calculating the number of years, the number of seconds on the given number of years. Okay, let me just go total number, or I can just go total seconds. I can simply go, that is actually equal to number of years multiplied by number of seconds in a year multiplied by seconds in a year. So this variable here will actually hold the total number of seconds on the given number of years, right? So if we are given 10 years, this will contain the total number of seconds in 10 years. Yeah. Okay. So what else we want to do? So what we want to do now is to simply go final, is to modify our final population size. We do know that every 7 seconds, what's gonna happen? people going to be born. Okay, so what we can do is to simply say total seconds divided by the number 7, because we want to see how many times does 7 go into total seconds. We simply do this. We then go final population size is equals to total seconds divided by 45, because every 45 seconds people they get into the country, right? So final population size minus total seconds divided by 13. Now, why did we use the minus? Why did you subtract and not add? It's simply because people will be dying every 13 seconds. I don't necessarily have to put comments, but for your sake, you guys, I can just go add new born all, add all new born people / kids or whatever into the current population size. Then you go add all immigrants, supposed to double M, add all immigrants into the current population size. And then lastly, you've got to remove all people who died in the given period. Okay, now that we've got that, what we then do is we simply go before I display my results, there's something I want to talk about. You see, what we used to do, in fact what we did is, on student A and B's solution, what we did is we said system.out.print the population, our output looked something like this: the population in number of years is However, there's something I want you guys to think about. Let's try to display. Let's put a 5. Look, we still get what we expected, right? But there's a little bit of a problem with this solution, and that's why I asked you guys to put a comment on the previous video, which was actually exercise 2.8. 2.11b which was exercise 2.11 from student B's perspective. There's a little bit of an issue on this statement. You see, when it comes to programming, you gotta be able to think of all possible cases, and there are certain cases that happened not to think about. So the question is, what if a user decides to put a 1? Let's do it and see what happens. So now our output is the population. The population in 1 year is that number here, right? However, like there's not, you see, 1 year doesn't, it does make sense, but it doesn't sound okay, right? It is supposed to be the population in 1 year is. So the question, how are we going to go about doing that? That's pretty straightforward actually. So we're going to go the population in this. So now we've got to determine whether to use a years or a year. We're simply going to do that by simply doing this. This is what we'll do. We'll simply ask ourselves whether this number is a 1, and if the answer is yes to that, we'll simply put a year, a word year, as opposed to years. And if our answer is not 1, we'll simply put years, right? And then we put the word is, or perhaps let's just remove this whole thing. Let's do it this way, yeah. So now let's read it through again. Number of years. This whole thing is supposed to be inside the brackets. So the population in some number year or years is whatever our final population is. So let's try it out and see what we get. Again, if you put a number like 5, it will work out obviously, but if you put a 1, the population in 1 year will be that. You see, we no longer have an S on the word year as we used to. So that should be it for this tutorial, you guys. But however, there's something else we never thought about. Like, ask yourself, what would happen if someone give us a number like any negative number, for instance? What if someone give us minus 50? How our program is going to go about doing that? I'm not going to try it out myself. I'm not even going to run a program, but you should ask yourself that question and then try to give me an answer down below on the comment. Okay, that's pretty much it, you guys. And if you haven't yet subscribed on my channel, I would really appreciate it you do, because look at this, I'm leaving this link this way simply because as of the time of recording this video, I'm not yet qualified to do certain things, and I would need at least 1,000 people in order for me, subscribers, in order for me to be eligible to some YouTube features. So that's pretty much it, you guys. And if you haven't, if you think you can, and if you like this video, I would really appreciate it. You share it to your friends or whoever who's interested in Java. And what I strongly suggest you do is just, when it comes to YouTube, if you're looking for my channel, just go Maniquesco. Right on top or on the search bar, just go Maniquesco, and my video will pop up, as opposed to going Java programming or introduction to Java. So that's pretty much it, you guys. See you on the next tutorial, which is exercise 2.12. Cheers, I'm gone.